This is the Chem 1 lesson over limiting reactants. So this is still stoichiometry problems, but they're going to look a little bit different. Let's start back with our peanut butter and jelly example. If I have 20 slices of bread and 35 teaspoons of jelly and all the peanut butter I need, how many sandwiches can I make? So you're probably thinking about, well, if I have 20 slices of bread and I have 35 teaspoons of jelly, you're probably thinking about how many sandwiches can I make with each of those numbers. So you're probably thinking about, well, with the bread, if I have 20 slices of bread, and for every 2 slices I get 1 sandwich, that's going to be 10 sandwiches. So if I used up all my bread, I can make 10. With my jelly, if I had 35 teaspoons of jelly, and for every 3 teaspoons I get 1 sandwich, 35 divided by 3, that's going to be 35 divided by 3. Well, it's going to be 11 2/3, right? So 11 2/3 of a sandwich. So the question is, how many sandwiches can I make? Well, I can only make 10, right? Once I make 10 sandwiches, I'm going to be out of bread, and then I'll have excess jelly. So maybe you want to say, well, I'm going to make 10 sandwiches with excess jelly, right? I'm going to have some left over. That's limiting reactant. In this reaction of making sandwiches, I ran out of bread first. So that was my reactant that was limiting my reaction. Once I ran out of bread, I can't make any more sandwiches, even if I have extra jelly. So that's the same idea of a limiting reactant problem. You're given different amounts of reactants, and you just have to figure out what the most you can make. And the most you can make is actually the least amount, right? Because once you run out of one thing, you can't make any more sandwiches. So the limiting reactant is the reactant that produces the smallest amount of product. That's going to limit that reaction. It's going to stop. Once you run out of one thing, nothing more can be made. The other reactant would be called excess reactant or reagent. You kind of see both those words interchangeably. They pretty much mean the same thing. So we can find limiting reactant through stoichiometry. When you calculate limiting reactant, there's 3 steps. They're all pretty simple here, guys. Write your balanced chemical equation. We've been practicing that. Convert, right, to the right thing using the mole ratio. And then the new part, the really hard part, choose the smallest answer. Whichever one makes least is going to be the one that limits. So, our first example, what is the maximum mass of copper 1 sulfide that can be formed? So we're asked to find maximum grams of Cu2S when 80 grams of copper reacts with 25 grams of sulfur. So this looks a little bit different because we're actually given 2 starting numbers. And what we're going to do here is we're going to convert them both to copper 2 sulfate and then choose the smaller answer. So let's start off with 80 grams of copper. Convert that to grams of Cu2S. So we're going to have to cancel out my grams, get it to moles. The molar mass of copper is 63.55. So let's get that number in here. 63.55. Excuse my room. Okay, and now that we have moles, we can use our mole ratio. So let's see. For every 2 moles of copper, I'm going to get 1 mole of Cu2S. Now that we're to moles, we just need to convert that back to grams, but now we've got a new substance. So for every 1 mole of Cu2S, we're going to have to add up the mass of 2 coppers and a sulfur. You're going to get 159.16 grams. So multiply across the top and bottom, divide, round that answer to 3 sig figs, you're going to get 100 decimal point grams of Cu2S. Now don't put a box around it and call it a day. We don't know if that's going to be the least. We're going to have to do the other problem. So now we're going to start off with 25 grams of sulfur and do the same thing here. Take our grams, convert it to moles, but now it's sulfur, so we're going to use the molar mass for sulfur, which is 32.06. Then we're going to have to cancel out using that mole ratio. 1 mole of sulfur. Let's check our mole ratio here. For every 1 mole of sulfur, I'm going to get 1 mole of Cu2S. Now that we've got that, we can, let's see, get from moles to grams. We don't have to add up the molar mass again because we did in the previous problem up above, 159.16 grams. Multiply across the top and the bottom, divide, you're going to get 124 grams of Cu2S. So the question is, how much can we make? Well, we have to choose a smaller number, 100. That means we're going to run out of copper. So we could say that copper is our limiting reactant here, and that sulfur is in excess. We're going to have extra sulfur hanging out. Our next example, what volume of hydrogen sulfide gas is formed? Okay, so underneath hydrogen sulfide, we're going to write question mark liters, and we're given 8 liters of hydrogen and 7.5 grams of sulfur. So one we're given liters, one we're given grams. That's fine. We're going to convert them both to liters of H2S and then choose a smaller answer. So we're going to have 2 steps here. First, we're going to start with hydrogen. So 8 liters of hydrogen, 22.4 liters for every 1 mole of hydrogen. Don't forget your substance. Our mole ratio, this one's a pretty simple one. Everything's in a 1-to-1. So 1 mole of H2 is going to equal 1 mole of H2S. Then we just need to convert it out to liters again. Volume, yes. So H2S to 22.4 liters. And sure, you could crunch the numbers here on this, but if you notice, everything's ones, and we have a 22.4 up top and bottom. So mathematically, we're going to get 8 liters again. So now we're going to need to do the same thing, but this time with 7.5 grams of sulfur. So this time we're going to have to use the molar mass instead of those liters. Our ratio is still 1-to-1. All those coefficients are 1. And then we're going to have to take 1 mole of H2S and convert it to liters since we're asked to find volume. Multiply the numbers across the top and the bottom and then divide, and you're going to get 5.24 liters of H2S. So now the new part, choose the smaller answer. You could say that our limiting reactant here is sulfur, and this time we would have excess hydrogen, since it makes more.